Good day to all. Today we are going to see about that PLC architecture. See, this is the programmable controller replaced most of the relay panel wiring by a software programming. The software programming are ladder diagram, sequence list, functional block diagram, instruction list, and etc. There are 5 softwares for this programmable logic diagram PLCs nowadays. This PC programmable loader, printer, cache loader, EEPROM loader will have the processor, and this input output modules with the connections with the switches and machines. This process will have memory as well as this input output modules have a power supply. These are all the peripherals, and this is the external devices. This is the architecture of the PLC. Then each components of that PLC. First one is the processor. In that PLC, the processor used for microprocessor based, and that may allow arithmetic operations, logic operators, black memory moves, and computer interface, local area network functions, etc. Then the memory of the PLC. It is measured in words. That's then ROM, read only memory. Then RAM. The memories of ROM and RAM also there in that PLCs. RAM is random access memory, and PROM, which is programmable read only memory. EEPROM, electronically erasable programmable RAM. EEPROM, erasable programmable read only memory, and EAPROM, electronic alternately programmable read only memory, and bubble memory. These are all the memories in that PLCs. Then input output model of this PLCs. The modular plug-in periphery, AC voltage input and output, DC voltage input and output, then low level analog input, then high level analog input and output. Special purpose of modules, for example, high speed timers like that. Then stepping motor controllers, for example, PID and motions. The power supply for this PLCs is AC power supply. Then the peripherals of this PLCs are handheld programmer, which is a loader, CRT programmer, then operator console, printer, simulator, EEPROM loader, cache loader, graphics processor, and network communication interface, map and LAN. These are all the peripherals of that PLCs. See then the ladder diagram. This ladder diagram is also it's also called contact symbology. Is a means of graphically representing the logic required in a relay in a logic system. Here it is called rung. This straight line is called rung, and this is rail. These are all the contacts, which I said before. The push button is like this. This is also one of the button, normally open button. This is a closed push button. This is the output. Here it's one example shows here. One push button, open push button connected with the closed push button with a latching of open contact. See, it is rail, this rung, and this is called latch. It is connected with the first rung. we will see the simple program first. Here we will see the uh, OR operation. So what is that OR operation? As we know already, if both input is low, the output is also low. If any one of the input is high, the output is high. Input is 0 0 means output is 0. If it is one input is 0, one output is 1 means output 1. And here one input is high, one input is low, the output is also high. If it is 1 1 means also the output is also 1. 1 is nothing but blow. For example, if it is light, if 1 means the light will blow, if 0 means the light will off, like that. We will see the program here. See, as I said already, this is the rail and this is the rung. This is the normally open connections. The address of this connection is here and this one is here. The output of this one is here. This is the normal program for OR operations. If we switch on off any one of these switch, the output will on. That is the program, ladder program here we are going to use. Let's see, if I'll on any one of this switch or this switch, then the output will blow. See, now I on this switch, so the output is on here. Okay, if I on the switch here also, this output will blow. This is the ladder diagram for that AND operation. This ladder diagram is nothing but it is a program in the PLC. So we will use like these type of programs in that PLC. Now we will see one more program like AND operations. See, as we know already, what is AND? If both the input is high only, the output is high. For example, if it is 0 0 means the output is 0. If the output is 0 1 means also the output is 0. And if it is 1 0 also the output is 0. If it is 1 1 only, the output is 1. If any of the input is high, the output is also low. If both the input is low means also the output is also low. But when will be the both the input is high only, the output is also high. That is the AND operation. This is the ladder diagram program for that AND operation. This input I/1/0 is here and I/1/1 is here. These two inputs connected with here and this output is here. If I switch on any one of this, either this or this, the output will not blow. Only if I will blow both the two switches only, the output will blow. Because as we saw before, AND operations is for only both the input is high only, the output is high. That is the basic logic of AND operations. This is the program. Now we will see the output. See here. Here the input 1 I.0 is on, as well as this I/1/1 is also on. Then the output is 0.2/0 is on here. You can see here. This is on, this also on. So the output will also on. But the thing is, if I off this switch, the output will blow? No, it won't blow. Because here in this rail will have a supply over here. If suppose if I off this switch, then there is no connection between here and here, because this one is off. This is the, as I said before, this is the normally open connections. NO connection. NO connection means normally open. If it is normally closed means we will have supply over here, but it is normally open. So once the switch is on only, this part will close, which means the current will flow here to here. If it is this switch is on, then if it is this switch is on also, the current will come here, then it will go here, then the light will or motor will run. These are all about the PLC diagram. Thank you.